So the next topic I want to talk is of a different kind of a shock caused by natural hazards, right? And there are key questions that we have been looking at. One, we want to look at the economic impacts of disasters, right? We want to see how much of economic impact is there. There are a lot of studies which look at the macro level, but our interest is to look at the spatiotemporal variations using foot traffic. How many people are visiting a particular POI, like a restaurant, for example? How much is that decreasing when the disaster happens, when it is recovering over a period of time, right? So we look at the mobility to each of these different types of points of interest, and then we make some inferences in terms of the economic impacts. Two, we are interested in inequalities. We want to see how the impact of a disaster causes to make these inequalities more apparent, right? But also the impact of the disaster itself causes inequalities in terms of the consequences that are there. Three, if there's time, we'll talk about the system dynamics model, which integrates both the social and physical networks. And finally, I want to share some future work I hope to do with ADBI. So the economic impacts of the disaster. So we want to kind of look at if a region is hit by a disaster. So this is here is Puerto Rico, hit by Hurricane Maria, Hurricane Irma. And if we were to do analysis for this, or this is New York, are these inferences translatable across these different groups? How can we measure the business impacts in these different areas and so on, right? So there's a shock here, and there's a recovery over a period of time that actually happens. And the number of visits steeply drop immediately after the disaster. Slowly they pick up, and we want to quantify this particular impact that is actually there due to the decrease in the number of visits that are there to the establishment. And we want to do this by category. We want to categorize by big business, small business, schools, hospitals, train stations, and so on, right? So different kinds of POIs. So I just, in the interest of time, I'm just going to show you one specific example. So this is from data from Puerto Rico, in San Juan in Puerto Rico, the capital of Puerto Rico. And this is data over a period of time, longitudinal data, right? And there were two disasters. One is Irma and Hurricane Maria. Both of them hit this particular area. Here you can see the real data is shown in this gray dots here. So these are the number of visits that are changing. Walmart is a big box store in the US, right? And you can see how the visits are changing over time. This is the actual data. And immediately after Maria hit, you can see the steep drop in terms of the visits. This is the actual data again, right? And these are the predictions. This blue line is the predictions. If it were a normal situation, if there was no disaster, this is what the predictions would actually look like. The question is, can we make predictions, right, for one, the shock that is happening, right? And so that we can predict this significant drop that is there. And then can we predict what's going to happen after that so that we can translate that into dollar values and economic impacts and so on. So this is work with Taka, and we have developed some very nice machine learning models here to kind of predict this. And here you can see our predictions incorporating for the shock. And here you can see that the dip is captured, right, after Maria has actually hit. And you can see the significant drop in terms of the number of visits. And then you can kind of also see in time how this is actually changing, right? So this is based upon the machine learning model that we actually have built to estimate the business impacts after a disaster. So this is pre-disaster increase. Why is there an increase? Because a lot of people go for shopping to board their homes, buy water, food, and so on. And then there is a significant drop post-disaster. So we can then compute the dollar values associated with that. And we do this for all different kinds of businesses, right? Depending upon whether it's a gasoline store, grocery store, hospitals, hotels, restaurants, and so on. So you can see that these are shown here. These different POIs are shown here. And we apply the similar kind of a ML model to these different businesses in Puerto Rico. And after that, right, we can look at the cumulative impacts across a given region by aggregating the impacts of all of these different establishments that are there, right? here, one thing, as I mentioned, inequalities, right? So we are interested in knowing the urban-rural differences. And here you can see San Juan being the capital, right? That's shown here in blue. And the orange one is the rural parts of Puerto Rico. You can see that the disaster impact has a higher effect on the rural areas consistently across most of these POI types, including buildings, gas stations, hospitals, supermarkets, and so on. So rural areas are hit more due to these disasters compared to urban areas. And the impacts are different across different categories. In fact, you can see here that in urban area hotels, right? Like for example, they see a positive effect. That means people actually go to hotels. That's the place of sheltering for many rich people. So a lot of people go to San Juan possibly to actually be in the hotel. So hotels actually do make money during disasters, at least in the short term. But you don't see the same thing in rural areas, right? Rural areas, even the hotels are actually hit. So you can see that there's a big difference in terms of one, the POIs itself, but also to this urban-rural divide that actually might be there in terms of this effects. And we can quantify the dollar losses based upon these data that we actually have, okay? I want to then move on to the mobility patterns and how that reveals this inequality. Can we quantify this inequality more clearly, okay? And we are kind of going to, we're going to look at these inequalities that are there in terms of this evacuation destinations. So here we kind of use this mobility data to characterize where people go, right? Depending upon where their home is, depending upon their income, depending upon their family structure and so on, where are people evacuating, right? And here you can see that there is an inequality in terms of the income groups, right? So rich people, which is shown here in red, right? People who have income of more than 75,000 per year, not really rich in the US sense, but reasonably maybe in the 80 to 85 percentile, especially in Puerto Rico, right? So they move farther away from their home. That means they go as far as New York, they go to Florida and so on. So they get off the island and go farther distances. The income range in terms of this destination, they also go to destinations which have higher incomes. That means they're not rundown places, they're not poor neighborhoods, they go to richer neighborhoods. They go to areas which have less power outages, and they also go to the damage rate in those areas that they move to also have less damage rates, right? So you can see the significant difference in terms of how these evacuation patterns are there between the rich and poor using this mobility data. And these graphs actually show that. Then the question is, can we model these recovery patterns? So if I want to look into the future, make some guesstimates of how this would look like, can I use these recovery patterns? And can I kind of make some predictions based upon this? And I won't really go into the details of this particular model here. So this model considers both the social network and the physical networks and the interdependencies that exist, right? So people come back because the water is working, the roads are there, the schools are operating and so on. And governments don't want to fix these things until people come back. So this is this classic chicken and egg problem. So we need to consider the dependencies that exist between these two systems. And how can we model the dynamics using this mobility data that is there so that we can predict what these tipping points are within these systems. And then we can kind of look at the recovery trajectories of both these social and physical systems, right? So for this, we have developed a system dynamics model, which captures how the rate of people who are returning back to these communities would look like. And without really going into the details of the model, one key thing that we see, so this is again Puerto Rico, San Juan is the capital, urban area. You can see the interdependencies. San Juan is connected physically, but socially, right? Socially in terms of the flux, in terms of how many people move there to these neighboring cities and how many people come to San Juan before the disaster. So you can see that the connectivity, the social connectivity from San Juan to all these other cities is pretty high, and not so much for some of these cities like Ponce and Humakawa and so on, right? So they're actually much more, not very well connected. What we see is cities which are connected very well to large urban centers recover much faster because of these social connections that already exist between these cities, whereas cities which don't have such social connections do not recover as fast, right? And some of them fall behind, and it shows in terms of the longer trends where people move out from these areas because they don't have job opportunities, because they don't have, and then governments can't fix things because they don't have a good tax base and so on, right? So these social connections in terms of mobility patterns is really a good indicator of and a predictor of how and when these cities would actually recover. So this social index is very, very important. And these are some results from the social infrastructure model. So you can see that this is for the education sector. You can see the number of visits slowly recovering, right? After the Maria, especially in the universities, people start coming back to the schools. This is the holiday break. So you see a decrease here. Similarly, for the visits to hospitals and so on, it takes about a couple of months for it to really come back to the normal stage. So this is coming from a model which is a good fit to the real world data. Okay, so that's a quick summary of some of the disasters work we're doing with this smart mobility data from cell phones. The last thing I want to share, and then we can move on to the summary, is the vast amount of work we do in the smart mobility and ride sharing space, right? So if you see any city in the last 10 years, they have been transformed by smart mobility applications, be it e-scooters, be it Uber and Lyft, electric vehicles, different kinds of new mobility solutions are popping up. But what is missing is a holistic understanding of the impacts of these kind of new smart mobility solutions. So my team, we really look into these issues as to, okay, the goal of all of these new mobility is to reduce congestion, but are they really reducing congestion, right? Are they really making things better for people? Are they causing more inequalities in cities? Are they really pricing for all the externalities that are there in these systems? So these questions are drivers, and we have collaborations with various partners in New York City to understand these type of questions. So we use, again, GPS vehicle data. So for example, one big issue in New York City is the significant increase in Uber and Lyft kind of trips, FHV trips, after 2013 when regulations has been changed. And that has caused a significant displacement in the traditional medallion taxi drivers in New York City. And recently, last year, some of them are bankrupt, and some of them cannot pay their loans, and some of them have committed suicide. So there's a human impact to what's really happening on the smart mobility sector. So we are interested in, one, seeing where the inequalities are, right? How can we come up with better pricing solutions so that we can kind of come up with an integrated holistic system that works for almost everyone, right? And we can reduce these inequalities. So that is really our focus. And specifically, we have looked at some of the operational issues in terms of seeing how the presence of more Uber drivers actually increases congestion, and they don't go to some certain areas which traditional taxis go to, leading to some inequalities. And the pricing is also very funny. I mean, it's not really, they have surge pricing, which doesn't really consider all these externalities. And so we do collect this kind of data to understand these type of questions. So that can be, it's a nice preview to my next talk. I think Sitaram was kind of motivating me to make another presentation. So this is an ad for my next presentation. If someone is interested, we can certainly talk more about this. So in summary, this high resolution smartphone data provides us with very good understanding, in spite of some of the limitations it has, very good understanding of the economic impacts as measured by the foot traffic for different kinds of recovery in cities from disasters and pandemics and economic impacts. Particularly questions related to inequalities, questions related to how different types of control measures, like in COVID-19, could lead to some restrictions and lead to recovery of these cities, and looking at more broadly sustainability impacts, right? And I would be very excited to kind of discuss some of these topics into the future with the ADBI economists and researchers, especially in terms of looking at COVID-19 impacts using this mobility data, estimating the economic impacts using mobility data after disasters and COVID-19 type of shocks, right? Looking at inequalities, looking at the externalities and the impacts of these kind of systems. And then also looking at smart mobility impacts, both in terms of emissions and sustainability and the impacts on cities, right? So super excited to share some of my research here, right? And look forward to continuing our work with ADBI, working with the ADBI staff on topics of making an impact on the society. So with that, I'm happy to be here. Thank you very much. Happy to take more questions.